Hi, fourth grade. So today we're going to be talking about heat transfer. So I'm going to do something that I generally try not to do, which is I'm going to actually start the lab first and then go back and talk about it. That's because our lab requires very hot water today. So if you choose to do this lab at home, please make sure you get an adult's help. But it's very hot water that we're working with, so I want to get it started before my water cools off. So what you're going to need is a stick of cold butter. I just pulled it out of the fridge. And you're going to cut off just a tiny bit. And you are going to stick it on a metal knife. Lay that to the side. Cut off another tiny piece, the same size. Remember, we're scientists. I'm actually using the tablespoon tabs to help guide me. So you can do that if you choose to do this lab at home. Again, you do not have to do these labs at home. It's only if you want to. You will, however, be graded on the quiz that is after the lab. So we're gonna go ahead and stick these guys on. There we go. And get a glass. We're gonna put our 3 items in there. And without touching the butter, I'm gonna fill the glass about halfway. So now you would do that again and put it in a separate glass without water. I'll explain why in a minute. But Miss Bender's not gonna lie to you. I do not wanna waste my butter today, so we're not gonna put butter on the end of our control. We are just going to fold our butter back up and set it off to the side. So today we're going to be talking about heat transfer. And what I've done is I set up heat conductors and insulators inside our lab. So here's our jar. And what I've done is you have what's a conductor. A conductor is an object that allows heat or electricity to flow through it easily. So for heat, metal is a great conductor. So I put inside my cup a metal knife with a little bit of butter. Insulators are things that do not allow heat or electricity to pass through easily. So for this, I've used a plastic knife and a pencil, and we're going to see which one of these are a better conductor for our butter by seeing which one allows the heat to be absorbed from my hot water up through it into the butter to melt the butter. Because remember, the way heat transfers is from a very warm object, my water, to something that's colder than it, so metal. That's why when you grab metal and it's been kind of cold, it zaps that heat from your fingers and you can actually feel it. Your fingers go numb, especially if you accidentally leave something in the freezer that is metal. So heat transfers from the hot object to the cold object. Now remember, temperature is how hot or cold something is, but heat is actually talking about the molecules, how quickly they are moving. So it can be warm, but the molecules, the heat be low because the molecules are slowly moving. And the hotter the temperature, the quicker the heat molecules are moving. But it does mean 2 different things. Temperature is the actual number, how hot or cold something is, whereas heat is talking about those individual molecules moving and causing things to warm up and change its temperature. So we're gonna go ahead and leave that and see what happens while I continue to talk about our lab. So what you needed was 2 glasses and some very hot water. You needed 2 metal knives, 2 plastic knives, and 2 pencils. That's going to represent your metal, your plastic, and your wood. One of the cups you're going to fill up with water with your butter. Oh, no, sorry. I did that. I shouldn't have done that because he's out of control. With our water and and our butter. Now on these, the one thing I left off again is our butter, because Miss Bender does not want to waste her butter right now. I can't use it once I stick it to the end of a pencil, so I'm not going to do that twice. But in this cup, you wouldn't put the water, but you would put the butter. Miss Bender put the water on accident, but you would not. I poured it back out. As a control, you would just put the butter, not the water. So in lab, what I would normally give you before we even got to this step was your hypothesis. And your hypothesis is, what conductor melts butter quickest? Is it metal, wood, or plastic? And from there, you should know that you would have to do research, and that scientists can do research in a number of ways. They can do an interview, which is where they go and talk to another scientist to see what they have learned from doing a similar experiment. They can do research from a book that has been published. They can do research from the internet or a documentary. But you do have to make sure that that research is valid, not from Wikipedia. You have to make sure it's in a credible source. Once you've done your research, your question for your hypothesis was, what melts the butter faster, metal, wood, or plastic? Then you can come up with that hypothesis, that educated guess. It's educated now because you've done your research, and you can write down, I hypothesize, and pick either metal, plastic, or wood would melt the butter quickest, and then tell me why you think that. Because it's a good conductor, because it's warm all the time. Whatever you think from your research is a good reason why that object would be the better conductor. Once we've done that step in the classroom, we go into our variables. Now, I've gone ahead and done our variables today because, again, we're not in the classroom and this is a strange new world we're living in. So I've gone ahead and done your variables today. Your independent variable, remember, is the variable that scientists change. So we are changing the types of heat conductors. We're changing from a metal to a plastic to a wood. So that's our independent variable. Our dependent variable is the variable that changes because I changed the independent variable. So that means what happens to the butter because I stuck it on metal, or because I stuck it on the wood, or because I stuck it on plastic. And in this case, it changes the time it melts. So I'm keeping track of the time, and it changes the time that it actually melts. Our constant is the variable that is the same throughout the whole experiment. So throughout the whole experiment, our water temperature is not changing and our butter is not changing. But I put this like this because I was hoping to do an open conversation during this, but unfortunately I'm not able to do it that way. Miss Bender purposely added something as a constant that shouldn't be a constant. Now, it would be different from our control and the actual experiment. Pretend there's butter on top of my knives. The one thing that is missing is the water. So that's not a constant. It's not something that's there for both. So the actual constant, because we had to do this as a recording, I'm going to change it for you, is the butter. Because I would have butter on these, and I already have butter on these. The control is the glass without the water. We're taking away the heat. How quickly does the butter melt from each conductor without heat? So this is our control glass. This is our experimental glass. Now, if we were in class, I would also make you do a chart, because that is how we collect our evidence as scientists and how we can keep control of our thoughts as scientists. Not only do we document everything that we see, such as right now, the butter is actually starting to melt a little bit on the back of the metal, but it does not appear to be melting on any of the others. I would write that down, that it's been a minute and the butter is already melting on the metal. But this would be our graph, the way we can finalize our thoughts. We would put what type of conductors we're using, a pencil, a plastic spoon, and a metal spoon. I ended up using knives because I didn't have spoons, but if we did this in the lab, you guys would have been using spoons. And then you're going to put the time, and we would have in the lab documented the time each one of these melted, or as quickly as we could. So then after you have done all that and we have concluded our experiment, you guys would wrap it up with that nice little bow called a conclusion, where you tell me if your hypothesis was or was not correct. Remember guys, hypotheses aren't always correct, and that's okay. That's how we grow and learn as scientists. So if my cameraman will go ahead and zoom in, I didn't give it the amount of time. We normally have 50 minutes in the lab, but I don't think you guys want to stare at butter for 50 minutes on a video, so I'm rushing it a little more. But if you zoom in on my metal, you can see how it's already starting to melt and slide down a little bit right through here. And if I actually touch my knife, I can actually feel it getting warm. Now, my pencil, nothing has happened to my butter at all. It looks exactly like when I stuck it on there. My plastic, it has moved, it's shifted a little bit. And the plastic itself, you can actually, if my cameraman can zoom into you can actually see where the heat's already at on the plastic, which is kind of cool, where it's condensated up. It's actually warm right there, but it's not where my fingers are at the top. So that's kind of cool how you can see the heat rising in the plastic, but it's not quite as far up as it is in the metal just yet. And so that means that our metal knife is actually the better conductor because it's already melting its butter. And I would document that in my scientific notebook if we were in the lab. Now, I wanted to pull this out for you guys. This is my oven mitt. Inside my oven mitt, it's made of cotton, and there's wool inside here too to make it nice and fuzzy. But these guys are what's known as insulators. They make it hard for the heat or electricity to travel through it. So my oven mitt makes it hard for me to get burned if I'm pulling something out because it's insulating my hand. It's keeping it safe. Conductors such as metal quickly get hot. So this is a soup spoon that I use, and the way we use it is this little hook indentation actually sits on the side of the pot when you're stirring it. So this part gets hot because the oven heats the pot heats the soup, and then the soup heats the spoon. As the flow of heat moves from something hot to something cold, it finally heats my spoon. But this top part is plastic, so that way when we grab it to ladle out some soup or whatever, we actually don't get burnt because this part is an insulator. So in your own kitchen, you may see a lot of conductors and insulators that are constantly used for cooking and other various objects. So now that we've finished our video, because again, like I said, I don't think you guys want to watch butter quite like we would in the lab because I would have other activities while our butter was melting. That's it for our lab today. Like I've said before, you guys do not have to physically do the lab yourselves. You just had to listen to my video. However, if you would like to do the lab, you can time it and see how long it takes for your butter to melt or another object to melt. See what you can do, what your conductors are able to do with a little bit of heat. But now that our video is over, guys, I hope you head on over to that assignments tab and take your quiz on heat transfer. Bye, guys.